In this video, I'll explain how to find the limits by using graph and by estimating the values of the function. First, I'll do by using graph. So let's get started. Suppose f of x is any given function and we have to find limit f of x when x is approaching to a point A. Now, when does this limit exist? If the left hand limit equals to the right hand limit, that is, when limit x approaches to A negative, f of x is equal to limit x approaches to A positive f of x. When these two are equal, that means this limit exists. Now let's see how we find the limits from a graph. So I'll make a graph. This is x-axis, this is y-axis. I'll make graph. Two. Now, this is a graph of any function f of x. Now we have to find limits from this graph. Let's say we have to find limit f of x at 2. That means when x is approaching to 2, and we have to find limit f of x when x is approaching to 3. One more we'll find, let's say at 5. Now we are given the graph of a function f of x and we have to find these limits. The limits at the points 2, 3 and 5. First I'll find at 2. Now when x is approaching to 2, that means from left side and from the right side, then f of x is approaching to the point, let's say here is 2.5 somewhere, 2.5 from both the sides. That means limit x approaches to 2, f of x is equal to 2.5. The next one is limit x approaches to 3, f of x. Now here when we check the limit at 2 from the left hand side also, that means when x was approaching to 2 negative, it was approaching to 2.5, and when x was approaching to 2 positive, that time also it's approaching to 2.5. That's why limit x approaches to 2, f of x is 2.5. I'll write it down. Here limit x approaches to 2 negative, f of x is equal to limit x approaches to 2 positive, f of x equals to 2.5. That's why limit x approaches to 2, f of x is 2.5. Now the next one is at 3. So we have to find limit x approaches to 3 negative, f of x. That means when x is approaching to 3 from the left side, x is slightly less than 3, here somewhere. Now when x is here, f of x is approaching to 3. That means this limit is 3. And when x is approaching to 3 plus, that means when x is greater than 3, slightly greater than 3, then the limit is approaching to 4. When x is approaching to 3 positive, then f of x is approaching to 4. That means the left hand limit and the right hand limit at the point 3 both are not equal. So that means this limit does not exist. The third one is limit x approaches to 5 f of x. For this also we have to check both the limits. Now when x is approaching to 5 from the left side, that means here x is approaching to 5 from this side, then f of x is approaching to 4. When x is approaching to 5 from the right side, that means here, that time also f of x is approaching to 4. That means if these two limits are equal, then limit x approaches to 5 f of x is 4. Now another method to find the limit of a function is by estimating the values of that function. To do that, I'll use this example. This also can be done by direct substitution method, but in this video I'll do it by estimating the values. For that, I'll estimate the values of x square near 1. Now I'll take some values of x near 1. It can be 0.7, 0.8, 0.9, and from the other side 3, 1.2, 1.1. Here the values of x are going closer to 1 from both the sides. If we see on the number line, here is 1, here will be somewhere 0.7, 0.8, 0.9, and from this side 1.3, 1.2, 1.1, this way. Now when x is 0.7, the value of x square is 0.49. When x is 0.8, x square is 0.64. When x is 0.9, x square is 0.81. When x is 1.1, x square is 1.21. When x is 1.2, x square is 1.44. When x is 1.3, x square is 1.69. Here we see when the values of x are going closer to 1 from both the sides, the values of x square are also going closer to 1 from both the sides. That means limit x approaches to 1, x square is equal to 1. This is a very important result from limits. If you have seen my other videos, I have done this result by using trigonometric functions and unit circle, but in this video I'll be doing it by estimating the values of this function. To do that, I'll take some random values of x which are going closer to 0. So I took 0.5, 0.1, 0.0001. From the left side I took minus 0.2, minus 0.1, minus 0.001. At these values of x, I calculated the values of sin x by using a graphical calculator. And then we just have to find sin x over x by dividing this value by this value. So we got these values. Now, when the value of x and sin x both are positive, sin x over x is also positive. When the value of x and sin x both are negative, then also sin x over x is positive. as the negative signs are cancelled. Now here we see when the values of x are going closer to 0 from both the sides, the values of sin x over x are also going closer to 1 from both the sides. Here the value is 0.9588, then the value is 0.99833, which is greater than this value. The next value is 0.99999. And if we see from the other side, here the value is 0.99334. The next value is 0.99833, which is greater than this value. Then the next value is 0.9999. So by the definition of limits, when the value of the function approaches to a same value from both the sides, that means limit x approaches to 0, sin x over x is equal to the point 1.